All right, we are talking about equivalent expressions. You don't have this up here, but you need to have this up here. You're comparing this expression, and it will have an equal sign in the middle, compared to this expression. And so you, in your notes, need to write expression that has the same value on either side. Also, the key to this is that, like, the variables, they have to be the same letter for it to be an equivalent expression. So for this example, we're going to say that z is equal to 3. So I'm going to cross this z out, and I'm going to say times 3. And cross this z out, and I'm going to say times 3. And then I just do PEMDAS, or order of operations. So this would then be 24, because 8 times 3 is 24, plus 4 would be 28. Okay, and then work inside the parentheses. Multiplication is first. 4 times 3 is going to be 12. Still inside the parentheses would be plus 2, which would be 14. So we're looking at 2 times 14, because anytime a 2 is touching a parentheses, that means multiply, and 12 plus 2 was 14. 2 times 14 is 28. So these are equivalent expressions. Okay, remember that the variable, it has to be the same number. Doesn't matter what direction or what side of the equation it's on. Okay, we're moving on to combining like terms. This one has an x in it, and this one has an x in it. Also remember from our last lesson, if you have like terms, you have to include that symbol on the second one, because it tells you what to do. So this would then turn into, so it's 3x squared minus x squared. And if it's just a plain letter, there's an invisible 1 here. So 3 minus 1 would then be 2x squared. And then whatever's left over, you just write it out like your regular problem, plus 4y. Okay, this one has an x. This one also has an x, and it's the second one, so include the symbol with it. So 7 minus 2 is 5x. Write the rest of the problem, plus a regular 5. Cool? All right, moving on to factors. You take a common factor. We did this way back in chapter 1. Okay, you take a factor that factor is a smaller number that both of these have in common. So a common factor of 8 and 12 is the number 4. Okay, and then you put the rest of it in parentheses. 4 times what got you to 8? And that would be 2. You have to leave that x on there. And then symbol. 4 times what got you to 12? And that would be 3. Okay, we did this when we did like greatest common factor, and it's like distributive properties. I'm trying to think, it might be lesson like 1.7-ish. So if you need a refresher on that, you can look up on chapter 1. Okay. Let's practice with this one. A 5 and a 20. What is a factor or a smaller number that both 5 and 20 have in common? They both have 5 in common. So 5 is going to go on the outside. Put your parentheses. 5 times what gets you to 5. So you could put 1x, or you could just leave it as the letter x, because remember there's an invisible 1 in front of there. Use the same symbol. 5 times what gets you to 20? The answer is 4. Okay. Same with this one over here. 7 and 21. What is a factor or a smaller number that they have in common? They both have 7 in common. I want you to try and figure out how to get there before I get there. 7 times what gets you to 7x? With an invisible 1 in front of it. Use your same symbol. 7 times what gets you to 21? The answer is 3. Okay, this one will be different because this one has a squared. So, what do 3 and 9 both have in common? They both have 3 in common, but if you look, both of these have x's in common. You're okay. They both have 3 in common, but they both have x's there. So you can put 3x on the outside. If you look at all these other ones, only one of them had an x. So, how did we get from 3x to 3x squared? You multiplied by an x. Because here's an x and here's an x. And if you put x times x, that turns into x squared. I know it's confusing, but we will move on. 3 times what got you to 9x? 3 times 3 is 9, so you would put a 3 there. You don't need to put a 3x because this does not have an exponent. Okay. All right, moving on to our last section. Distributive property. Anytime a letter or a number is touching parentheses, it needs to share the love and it needs to multiply by both of these things. So this would turn into AB because you're multiplying those two letters together. Remember, if letters and numbers are touching or if letters and letters are touching, it's multiply. Okay, keep the same symbol in the middle. A and C would turn into AC. This makes more sense when we're talking about numbers. So this 5 times 30 would turn into 150. Keep the same symbol in the middle. 5 times 4 is 20. Combine those and you get 170 as your answer. Okay, it's the jumping. We like jumping. Jumping is fun. I'll do an example right here. 8 times 5x would turn into 40x. Keep your same symbol. And then do your second jump. 8 times 3 would be 24. Because we don't have the value of x, it is just going to stay as an expression because we can't solve it because they didn't say, hey, x is equal to 2 or x is equal to 24. So it just stays that way. We'll do one more example over here and then we'll be done with our wheel. So 3 times 2x would be 6x. Keep your same symbol. And this would turn into 27. Again, they did not give us the value of x, so we will leave it as an expression. On the outside, you can practice your jumping on this one. On this one, you can combine some like terms, like how we did here. There's not a whole lot of solving for the answers. It's more just combining like terms and doing your distributive property of jumping over. Okay, now we're turning over to the book. Okay, We are on lesson 7.8, page 405 in your book. And on problems 3, 4, 5, and 6, we are just combining like terms. Problems 7, 8, and 9, we have to do the distributive properties or the jumping or something else. So, I see a plain 16. I don't see any other plain numbers, so then I'll look for other like terms, and I see that these both have P. So I'm going to circle the first one, and on the second one, I'm circling it with the symbol that's in front of it. So I'm going to rewrite my problem of 16 plus 13 minus 9 would be 4, tack on that letter, 4P. I'm actually going to switch colors so you can see what I'm doing. All right, number 4 is tricky because on number 4 it has a squared. And I want you to think of squared as a completely different term. Even though they all have y's in them, if it has a squared, I want you to think of it as a separate thing. So I'm going to combine 13y and 8y. I'm going to rewrite my problem. Y squared plus, what is 13 minus 8? I would get 5y. Okay. Based on our wheel that we just did, you have to jump, because this number is touching this parenthesis. So I'm going to jump, and that's going to turn it into 10h, because you multiply them. I'm going to jump again, and this is going to, and keep your simple. Jump again, 5 times 3 is 15. Okay, then I'm just going to write the rest of my problem, plus 3h. Okay. Then I'm just going to combine my like terms that I have. I have an h over here. I have an h over here. Make sure you have your symbol. I'm going to rewrite it. 13h plus my plain number over here. That should be your finished answer. Okay, moving on to question number 6. I want you to try and do it by yourself. You're combining similar terms. Remember, the second one, you always have a symbol in it. I see a plain number here. I see a plain number here, and I have to include that symbol. So if I rewrite that, that's going to be 19. And I'm just going to go with the next symbol that's available to me. I'm going to change colors again so that you can see how I combine my terms. And I have 18n. The reason why I did not put that in there is because this is the first term using the letter n. So anytime you're talking about the first term, you don't include this symbol. It's always when you're doing the second of that term. So this is the second term that has an n in it, so I'm going to include my symbol in that. So 18n minus 14n would be 4n. All right. So now we're kind of switching gears and not just combining like terms. We are writing equivalent expressions. This one, you're doing the jumping. So 2 times 9 is 18. Keep your same symbol. 2 times 5k would turn it into 10k, and we don't have any symbols that we need to combine, or like terms that we need to combine in this, so that would be your final answer. Number 8 and also number 9, it's the one where you have to find the similar factors, the greatest common factor that they have in common. So 4 and 8, you have to go through your factors, which are smaller numbers, and what numbers do they have in common? And both of these have 4 as a smaller number in common, or a factor. So I'm going to put 4 on the outside, and I have to put my parentheses. 4 times what got me to 4D. 4 times 1 gets me to 4. So either you can put 1D, or you can just leave it as plain D. A plain letter is the same thing as a 1 and a letter. Okay? Keep your same symbol. 4 times what got you to 8? Answer would be 2. This is your answer for problem number 8. Number 9, they both have P, and so in all reality, you could just combine those like terms. And you could say it's 56P. However, they want you to do distributive property with it and put the parentheses with the number on the outside. Keep your same symbol in the middle. Give you a minute, see if you can come up with the right answer. What is a factor that both 21 and 35 have in common? If I go through my multiples, I know that they both have 7 as a factor. 7 times what gets me to 21? And that would be 3, and I can't leave off the letter, so you have to put the letter. And 7 times what gets me to 35? And that would be 5, and it has a letter. Can't forget the letter. So that's the answer to number 9. On your worksheet of 7.8, you only have to do the front. You do not have to do anything on the back. You also have a practice sheet that goes with it today, and it says identifying parts of an expression and combining like terms. You do have to do all of this. It is a lot of work today, but I know you can do it. Have a wonderful day. See you later.